Hello everyone, welcome back to ANR Academy. Today we are going to discuss shortest distance between skew lines topic. Before going to discuss the shortest distance formula, let us discuss first about what are skew lines, and then we will discuss about projection of a vector A bar on B bar, and then after we will discuss the formula for shortest distance between skew lines. The question based on this topic is very important in all entrance examinations like JEE and KSET, EAMCET, whatever it is. First, skew lines we will discuss. The definition of skew lines is the lines which are non-parallel, non-intersecting. They are known as skew lines. And the example for this, circus monkey is the best illustration for skew lines. Suppose that there is a monkey that is walking on a tight rope. A circus monkey walking on a tight rope, balancing with a stick. This is the best example. Here, this tight rope is a straight line, and here the stick also another straight line. While walking a monkey on the tight rope, these two lines do not intersect, and the balancing line which you have here, that is always non-parallel to this. Then only the monkey balance on the rope. So skew lines is nothing but the lines non-parallel and non-intersecting. Next, let us discuss projection of a vector A bar on B bar. Concept of projection now. Suppose that there is a vector A bar and another vector here I am going to select. Suppose that is B vector. Now you need to find projection of A on B. That is, you have to drop a perpendicular from initial point to B and final point of A to B. Here, after dropping perpendiculars, you will get a new vector here. This is known as projection vector and its length is known as projection. Suppose that if you transfer a vector to this place, these two are of same length and same direction, so that it is also a vector. Assume that angle between A bar and B bar is theta. Now to find the projection, what I am doing, observe. We know that angle between two vectors formula using vector algebra, cos theta equal to A dot B divided by modulus A into modulus B. The same cosine angle using trigonometry I am going to write. Using trigonometry, cos theta, that is defined by adjacent by hypotenuse. Adjacent here, adjacent to theta you have projection. So here I am going to write projection which is divided by length of hypotenuse, that is modulus A. This is the definition. Cos theta equal to A dot B by mod A mod B from angle between two vectors. and this is defined by just trigonometric ratios. Now equating these two, here modulus A gets cancelled and we get projection formula now. Therefore I can write projection equal to simply A dot B by modulus B. This is the formula to find projection. So now let us move to shortest distance between two straight lines. Suppose that there are two straight lines which are r bar equal to a bar plus tb bar and r bar equal to c bar plus sd bar. Then to find the shortest distance between these two skew lines, there is a formula, that is box of a minus c bd whole divided by modulus b cross d. Due to distance, put modulus sign for this. Let us see the proof. Suppose that this is first line and this is second line. Equation of first line is given as r bar equal to a bar plus tb bar, where t is any real number except 0. And second line r bar equal to c bar plus s into d bar, where s is any real number except 0. R bar equal to a bar plus tb bar indicates a straight line which is passing through point A and parallel to B vector. So here I am going to mention a point A which is on the line. Clearly it is parallel to a vector B bar. Next, R bar equal to C bar plus SD bar you have, that is passing through the point C and it is parallel to a vector D bar. Now you need to find shortest distance between these two skew lines. Suppose that this is the perpendicular distance between the two lines. Here the two lines are in space, remember. Right. Clearly this D bar and B bar, which are perpendicular to this required length, right? Suppose required length, this is shortest distance. Assume that if it is a vector, shortest distance directional vector I am going to write, which is clearly perpendicular to both B bar and D bar. Shortest distance directional vector I am going to write, which is perpendicular to two vectors B bar and D bar, so that I can write it is lambda into B cross D. Why? Because suppose that if you have two vectors A bar and B bar on a plane, then the vector perpendicular to both A bar B bar is denoted by A cross B or modulus some lambda into A cross B also. Why? Because along the direction you will get the vectors with any length. Perpendicular vectors usually denoted by lambda into A cross B. So here shortest distance directional vector lambda into B cross D. Now observe what I am doing. Just I am going to select this figure and I am going to rotate this. Yes. See now the figure. If you join A and C, what happens? Observe. By joining A and C, this is AC vector or CA vector depending upon the direction. A to C you have here AC vector it is. and these are the perpendiculars. Here perpendiculars dropped from C to here, A to here, so that clearly now this shortest distance is acting as projection. Projection of what? Projection of AC on shortest distance vector. So I am writing projection of AC on shortest distance directional vector. Just now we discussed, if it is A bar, to find the projection of A bar on B bar, the formula in the numerator you have to write their dot product, and in the denominator part you have to write modulus of B. The same here I am going to apply now. This is vector AC like previous vector A bar. Projection of AC we need on shortest distance directional vector, that is lambda into B cross D here. So now I am going to write projection of AC vector on lambda of B cross D. That is, here you have to write in the numerator their dot product, that is AC dot product with lambda of B cross D divided by modulus of lambda of B cross D. Using the formula A dot B by mod A, you got this result. Neglecting lambda on numerator and denominator, we get AC dot B cross D divided by modulus B cross D. You have one dot and one cross, so that you can write box AC vector, B vector, D vector divided by modulus B cross D. Also you can write, if you write AC as OC minus OA, you can write C minus A vector. Since distance always positive, I am going to put modulo sign. AC vector you can write OC minus OA, that is C bar minus A bar. Next BD, for whole you have box, and then in the denominator part B cross D. Due to modulus sign, I can write A minus C also, box of A minus C B D whole divided by modulus of B cross D. This is the proof of shortest distance between two skew lines. Just this is based on the concept of projection. Here projection of AC on shortest distance directional vector we are going to find. Here this is the perpendicular dropped from A, and this is another perpendicular that is dropped from C, so that this is known as projection. And also this shortest distance directional vector which is perpendicular to both B bar and D bar, so that the directional vector along shortest distance, that is denoted by lambda into B cross D. And hence with the help of projection formula, finally you got the result modulus of A minus C BD by modulus B cross D. I hope you have understood everything. The students, those who are watching my videos, please subscribe the channel and don't forget to like, share and comment. Thank you so much.